recording करना है यार.
Okay. Good afternoon. So now we will see the demo of SLA. So that is stereolithography. I think sir has explained some different types of 3D printing techniques. So material extrusion, binder jetting, wet photopolymerization, laser powder fusion, sheet lamination, and then direct energy deposition. So 7 main types are there. Within that, we have first one, wet photopolymerization. So in that we have SLA and then DLP. So SLA is stereolithography, and then DLP is a directed light projection. Okay. So that is the thing. So we have this SLA printer from Farm Labs. Okay. So so this is SLA technology, and then we have DLP Anycubic. Okay. So we'll see both the things. Yeah. So actually this printer comes with the 3 parts. Actually this is a printer. Bed is here. Actually this is a bed. So part will be printed here in a reverse. Okay, here I will show, open it and show. And then this is a screen, projector screen, and the projection will come from bottom. Okay. So actually SLA uses a laser, UV laser, and then DLP uses a projector. Okay. So here laser will cure the resin point by point. So in DLP the projector will throw the project whole screen. Okay, if square is there, through the projector whole square will be cured at once. But in laser or in SLA, it will go point by point or a little bit line by line. Okay, so that's how this is more accurate than DLP. Okay, so that is the difference. There we will use a projector, will cure a whole one layer or screen. Okay, by throwing the light. Okay, so here we will go by point to point. Okay, so so this is a resin border. So we'll put in this one in back side here. Okay, so now we are using clear resin. We have different materials. I will show there on the slide, sir. So we have now we are using 2 types. One is gray and then one is clear resin. Prints will come like this. So this is clear resin. This is gray resin. Okay, so gray color is this thing, and then that is transparent resin. Okay, so those are the 2 materials we are using. Since we are already put this clear resin, I will use this thing. Okay, so actually this has a sensor, RFID tag we will be using. We can't use other materials, or we have to borrow the material from this company itself. Okay, that is a customized setup. Okay, we can't use other materials or customize what we prepare. Okay, so if we prepare, we have to prepare that much accurate material. Okay, and then we have to fill it here and then use. Okay, so let's put it back. So it will detect actually, and then it will see check also, like this cap should open one like inside it. Okay, so that the fluid or resin should flow inside the tank. Okay, so this is a this is a build plate. Okay, so here, so it will be like this, or it will be going printed like this. The part will be printed like this. It will be reverse. Okay, so the laser will be coming from bottom. Okay, so before putting this, you have to clean this with the alcohol. Okay, then we have to insert. Okay, since so we are already prepared, so we have cleaned. Okay, so and then this is the so this is a platform which will move the resin every layer. Okay, so if one layer prints, it will cover the resin like to the platform with the resin. Okay, so it will level the resin. Okay, so and then this is a bed. Okay, which is removable, and then you can see so that screen, so which where from where projector will come or laser will throw the light. Okay. Okay, so this system is very smart. It will detect everything, whether we remove the platform, whether we remove the bottle, whether we remove the bed, everything. Okay, so it will confirm and then it will ask for confirmation. Okay, so then this I'll remove this also. See, it has all the parts has a sensor. Okay, yeah, and then we have a camera. So like we can record the printing time lapse also. If you want to show any presentations video or something, so that can be taken from the slicer and then it can be used. Okay, so this is the thing, and then I think this is a control panel where we'll control all the parameters. So this is similar to your smartphone, or like if you use any electric scooty or something. So we have similar setups with respect to this printer. Okay, so this will show the status, whatever I said, all the parts have a sensor. Okay, so now it has detected all, everything is fine now. Okay, so if not, it will ask and then we have to go inside and then we need to confirm. Okay, till then it won't show the status ready in the slicer. Okay, so after we confirm all these things here, then we can print there, otherwise it won't take the print. Okay, so and then so then it will show the status, or like how much resin is remaining in the bottle. So it is showing now it is 400 ml. Okay, and then which type of resin also, because it has a RFID tag, it has stored every information there. Through that it will detect. Okay, so yeah, I will go for next. So these are this is a history. These are all the parts we have printed previously. Okay, so again I can add here and then we can print again that thing itself. Okay. Yeah, so another one maintenance part is we can clean this bed platform. Okay, so print cleaning sheet, I will say this thing. Okay, if I start, you can see it will show some light. It will create a sheet and then we have to remove it, so that the bed or whatever the screen is there, it should be clear without any obstacles or any deteriorations. Okay, so now I have to remove that thing. Yeah, you have to use the gloves. That is all. Okay. Okay. So that is one thing. Before going for print, we'll print that sheet and then it will clean the bed. Okay. So next thing is so all these general settings. So we can see the about printer. So this is form 4, coherent vessel. Okay, so that is a name, and then we can change the name also. Okay, so we can change the name. So your name and your printer name, whatever you can do, you want, you can do it. And then so this is a form 4 model, and then firmware version, and then we have storage. So we have around 22 GB of storage available for this. Okay, and then MAC address and everything. Okay. So that's what. about the printer, and then we can select the region. Based on those things, they will give the firmware updates and all. Okay. We have a language selection, advanced capabilities. I think I don't have anything. So analytics, this is what the camera things. Okay, so we can record, and then what is the time, printing time, how much it will take, and those things. Okay, so these are, and then resetting, factory data reset, everything. So those things are there. And then connectivity, as of now we are using Wi-Fi. We have Ethernet capability, Wi-Fi, and then remote printing monitoring. So like Wi-Fi and then Ethernet. As of now we are using Wi-Fi. So that PC we are giving the print here. Okay. So we have one. This is a TDPD ST1 Wi-Fi, a local like universal Wi-Fi. Where that PC and then this printer is connected. All the our systems are connected to that Wi-Fi itself. Okay, and then firmware updates we can check here, and then we can download, and it will automatically install the things. Configuration, we can switch on and off the camera notification. So this, it will tell, it has speaker, and it can speak whatever the error is there, it will tell. Okay, and then we can set that volume, isn't creating timeout screen, everything we can set. So these are calibration things. So tools, align the build platform, drain cartridge. Okay, if you want to drain it. Okay, and then if I want to change the resin, I want to put the gray resin, I have to drain it. Okay, so I will remove that bottle, but in this, so I have to drain that one. I have to clean this whole platform with the alcohol. Okay, so without any track of this clay resin. Okay, then I can add the gray resin. Okay, and then inspect optics. That's what, that UV laser. Okay, and then level the printer, reprogram the tank, and then move the motors. So these all calibration has been done already, so I will not touch anything now. Okay, so if it is not giving good prints, then we have to go with these things and then calibrate it. Okay, so support, as you know, so we can give the queries to Formlabs. Okay, so visit Formlabs support for guidance, or submit the ticket, like support a ticket for failed prints, and then you can send the diagnostic information, everything. Or remote assistance also is possible. They can access from there and then help us. Okay, so yeah, I think we are done. So this is what, okay, so this is what the printer hardware part is, and then we have these two parts. So after the print, so this is the cleaner. Okay, so once we get the printed part, if a part is hollow or any support structure is there inside, so we'll put that, or whatever part is there, printed part, we'll clean here, so that the remaining the support structure or whatever remaining resin is there, it will be cleaned by the alcohol there. Okay, then after that we will be having alcohol content in it, so we'll be curing that thing here in the ultrasonic this thing, dry. Okay, so we'll be dried, and then so we'll get those parts whatever you saw now. Okay, so now we'll see the slicer. Okay, yeah, that piece. solid part or that will be converted to STL, okay, standard tessellated language part, and then we'll do the slicing. So I will take, so they have created already a folder for you. Okay. So we have a solid part. So just see the demo, like within 10 to 15 minutes, it will see everything. Okay. So this is a solid part. We can directly import this solid part also, or else .stl also, or else they have already created a form. So now I will take this. So this is the part we have created. Okay. So now we have so since I told it is a smart, so we have one click option. It will set everything. Okay, if I click that thing, so set up your print. So this is somewhat, it is not doing good. Somewhat slight is there, so that's why it has given the support. Support is not needed for this part also. Okay. So let's do the manual slicer. So yeah, so this is a default design or dimension by which we designed by us in a SolidWorks or whatever CAD software. Okay, so we can expand the size or else we can reduce the size. So now it is by default 1. If I want to make it double, I'll just say 2, so it will be bigger. Okay, it's much bigger. Okay. So if I want to reduce, so we can go less than this also, 0.2. Okay, so that scale up and scale down we can do here. So whatever the part we can reduce. Okay, we can reduce or we can expand also. Okay. So I will make it 0.5, so that we will make it fast. Okay. We'll see, it will show the time. We'll see. Okay. So or else if you don't want that scale up or in percentage, you can do with the respective dimensions. So let us say if it is 1. So this is a default. If you want to change the x, y, z or length and height, whatever. So if I want to make it 50, I can change that. So if I change one dimension, it is changing x, y, z. Okay. So this is what we can do with these things. So this is a sizing or scaling up and down. Okay. So now orientation. Okay. So we can change this. You can tilt. Okay, in whichever direction you want. Okay. So whatever base you want. If I click this one, so it will be like this. These orientations are. Or else you can like rotate or turn the things with respect to x, y, z. Okay. So yeah, selecting the place. So this is orientation, and then support. Okay, so I give the parts to like some overhangs will be there. If arc is there, so if you want to print those things, it will go layer by layer. So when it comes to upper arc, so if it doesn't have any support, then it will fall down. So for those things we need a support. So there, like if you can customize the support, like what should be the strength of support, what should be the height, and then so again the support is not needed after the print. Okay, so that way we will waste the material or we will throw it. So we should reduce the material also there by giving the customizing the strength of that support structure also. So those parameters are here. You can do the auto placement. So when I say auto orientation or auto one click, so it will do optimized placement, where you will get a less support structure, or where it will use the less time, less material, whatever. It will optimize. Okay, so there we can see. You see this closely. We have this overhangs. Okay, so it will optimize those. Or else, if you want customized things, we can do. We can give the manual values. Okay, So yeah, pillars, rafts. So we can change all these things. And then layout. So we can change this layout, size and all. If you want a lesser place. Okay. You want multiple parts, you can. Okay. Now you have got 2 parts. Again, I want to create another one. So you can multiply the parts here. Okay. So you can create the array of models and then you can do the mirror. Suppose if one part you create and then do the mirror. Like that mirroring we can do in the CAD software also. Okay. Yeah. So and then spacing in between the every object. So all those things are there. Okay. So placement of those things. Yeah. So and then they have already made the hole in this thing. So if hole is not there, if it is a complete solid, we can make a hole here so that if any the part is hollow, so we want to drain the resin from inside. So then you can see that we have printed those buildings inside. Things are hollow to reduce the material. So we have created one hole there to drain the resin inside. Okay. So if hole is not there, we can create a hole. So you can customize the wall thickness of that. Okay. So and then feature size, how much you want, or else accuracy. Okay. Yeah. So if you want any texture on that part, you can see whatever texture you want. You can click and then you can make texture. And then if you want, you can write our name on that. Somebody who's not cutting. Okay. So we have 2 options: emboss and then engrave. And you know the difference. Okay, those options are there. And then text size, increasing the so depth. So if you do the engrave, what is with the depth? That's what these things are there. So now we'll go for the print. After all doing these things, you can see here right side. So how much, what is the volume, how much ml of liter of resin it will take, and then which printer is connected. Everything is here. So now till now it was not ready. Since we did all those things, the printer is showing ready now. Okay, so we can see material is clear V5 and the layer thickness is 100 millimeter. So this accuracy is 25 to 250 micrometer accuracy is there. So that range of layer thickness you can. Okay, so yeah, so time estimation is 20 minutes. Within 20 minutes it will print and give. Okay, so volume is all those things are there. Okay, yeah. Anything else? Shall we go for print? So you can add it to the queue also. You can just say print also.
The support structure it automatically take, or you have to give them some.
Both the things. It will take automatically or else you can do. So we have different support. So tree is there, or straight, you can say cube or rectangular part is there. So those things are there. We can say in 15 months when we are doing 15. So this is also connected to EPD, that Wi-Fi I showed here. Okay. So now we set things now. So we got a pop-up. Now if we say play there, then it will pop up. Actually, it will heat up around. Guess it. So I think it is preparing. So we can heat up a little bit and then it will start painting. Okay, this one is painted. ಇಲ್ಲ ಅದು ನೋಡಿ ನಾವು ಕೊಟ್ಟಿನ ಲಿಂಕ್ ಸೇರಿಸೋದು That is the space.
Totally intro video recording.
वो आप पिक्चर सेंड नहीं कर सकते क्या ग्रुप वगैरह? तो हम कैसे ले सकते हैं पिक्चर सब?
This is also old block. This is library block. This is library. So this is library block.
Yes, central library. Both are same.
Both two blocks.
Here's some name है ये बैग है.
Library.
Yes. This gate is only for staff. This gate is only for everyone.
Nothing there. The same thing there. That is the same thing. This slicing also allow you to this is less accurate. This accuracy we have seen on this like this part and that part. You take images and you measure. You will know the accuracy. So you can see this slicing.
ठीक है.
Can we see the slicer? That here. So this is any cube that is formula. Okay, brief. We have any cube. Again, same things are all the slices will be same for it. Okay. So what I will do again I will take that solid part. Yes. Okay. Same part is there. So we'll see this thing. So again same things are here, and you can move. Okay. So this is out of bed. So you can move that. And then rotate. Okay, so these are the options. And scale again same. Whatever I said there. Okay. Scale it fade. Okay, or reset. Again same things are there. So if you want to do mirror, you can do with respect to all these axes. Okay, and then you can change the layout also. Layout is orientation of the with respect to bed as well as part. Okay, you can see the models placing like what we did, multiple parts. Okay, with those orientation. Okay, so models placing between we don't have here. That's what I showed here. Same thing. Okay, so angle and then spacing between those things. So I think I will reset this. So again we have a clone, you can do the number of copies. That this we can do the layout. Okay, arrangements. And then so any orientation is there, auto orientation. I said one click there, so that is repair here, and then you can make hollow. Okay, which type of hollow? Okay, so this you have infill structure. So BCC, FCC, those things are there. Okay, so we can change the wall thickness, accuracy of that thing. Okay, so these things are there, and then punch is a hole, and then free cut. Okay, so if you want to do the multi-material like half one and then half different, so that we can slice differently and then do. So that is a bit difficult actually, but we can try. We should do with all proper pre-planned things. So again we can write the text. Fine. Yes. Why do you want your name?
No.
We can go.
No, that's fine.
Let us see. So here we don't need any support. Now so orientation is different now. See, I want to write support for her. Generate so as of now, for this part we don't want. This is a waste of material. You can remove it like so these two remain cutter and all those. But the support section will not be that much dense as a part. So like it is a removable, so that's why it is a less dense. Okay, we can select the machine. We'll be having different models there in DSP also. So we can select those. So here we have anechoic photon monophore. So we have selected that. So we have a standard resin normal, clear resin. Okay. So we have these different types of resins. Okay. It is already filled. I will show it. It is already filled. So it will show. You can see the layer by layer. This is the last part. So I will save this pen drive. Yeah, so this is a resin, you can see. Okay, so again this is a bed, so again the same. There we have a laser, here we have a projector. That's the difference. Here we can see the size. Okay. 235 into 230 into 395. I think 23.5 is the length, centimeter. So and then 23 centimeter is the width, and height you can go for 3.9 centimeter maximum. So 405. So now just go to 3. This is taking 50 minutes. 50 minutes. This and that is done 3 minutes. नहीं देखा so I think I don't know. I think tomorrow we can see that. It is 15 minutes. So that we can see.
Similarly, we have 15 we do have that. No problem, yeah. There are some more processes we have to do completed, so we'll explain. Right.
Your time check my work to ಅಲ್ಲ ಆಮೇಲೆ ಅದು ಲೇಸರ್ ಬಿಡ್ತಂದ್ರೆ ಅದು ಚೂರು ಗಟ್ಟಿ ಆಗ್ಬಿಡುತ್ತೆ ಹಂಗೇನಾರ ಆಯ್ತು ಅಂತ ಎಲ್ಲ ಮುಗಿದು ಅದು ಇಟ್ಟು ಸಿಗೋದೇ ಅದು ಸಾಲಿಡ್ ಸಿಗುತ್ತೆ just that is more on 5.
Yes, but there from bottom place on this area, then I guess but here it takes the printing speed is much faster there. So mostly for dental because so I use this that yes. So there are some physical on that.
What do you expect the response to be? I don't think anybody will just on the center group call.
बंद नहीं करना है, जगह में रखना है.
use before options, start and stop. Set the time. Okay, go for time. Please, value. And raise up the model.
Coming to business ಅಂದಾಗ ಅಲ್ಲ ಅವನಿಗೆ
रियली का प्रोडक्ट फाइबर्स नहीं
metal pedals additional magnets time same strength if you go for composite same strength and then you can use it with less product design pedals actually I think different for different I think it has some guidelines or nomenclature, so thickness should be of this. That is there. That doesn't issue for that laser.
नहीं रहेगा वो नहीं उसमें बोलते हैं वाटर प्रूफ इस्तेमाल करते हैं डायरेक्टली वाटर एक्चुअली वाटर प्रूफ में थोड़ी सॉलिडिफिकेशन वो बेहतर है अभी बेटर कलर
That's what you can building also select the So everything is
PLA में बल्ब प्रिंट किया
बोली तो थी रिसेप्शन में उसके बदले में क्या मैं सोच रहा सिटी का 6 बजे है बस
हाँ वो वहाँ से जाती है मेन गेट सामने से मेन गेट से जाती है उधर नहीं जाएगी इधर तक हमें को पता नहीं एक बार से
Towards 60 degrees Celsius, and it will take
405 for printing. So most of the ratings are 405. So here the ratings are 405 is normally available in the market. Here there is a layer actually. Polymerization what is happening inside. It's like a sponge or because of the same thing goes. So the parts which you see there, which are kind of transparent, they have liquid in them. Much aesthetic compared to the rest of the
Okay, after curing it changes the temperature because of the UV exposure. Yeah, backward. Transferring back.
It is necessary if you want to see the full potential of the strength of the material. But if you want it just for your aesthetic purposes, then it is not compulsory. Because that will have sufficient. It will really become strong after this test. It will achieve its fullest strength.
The recycled
Material identify